Hello everybody, this is the sixth clip of our chapter 3. Okay, so from last time we have learned that if we want to construct the equation of the line, okay, we need to know the point that this line is passing through and the vector that the line is parallel. And the equation of the line contains three forms. Okay, however, the second form and the third form usually is the one that we use the most. Okay, the first one is the vector form, which is r equals to the r0 plus vt. So this v is the vector that your line is parallel, and your r0 is the point that your line is passing through, or sometimes we'll write down as x, y, z, okay, equals to x0, y0, z0 plus vt. Okay, just like this. And then the other one is a parametric equation, which is x equals to x0 plus at, y equals to y0 plus bt, and z equals to z0 plus ct. Or the symmetric form, which you just solve for t in each of the parametric form. So you got x minus x0 over a, y minus y0 over b, and z minus z0 over c. And you can write this way whenever your a and b and c is not 0. Okay, this is the equation of the line. While the equation of the plane, okay, if you got this plane, you need one vector that is perpendicular to the plane, which is called a normal vector, and one point that your plane is passing through. And the equation of the plane will be a, okay, this first component of your normal vector, x minus x0, b, y minus y0, and c, z minus z0 equals to 0. And you can distribute your a, your b, your c, and then rewrite your equation into ax plus by plus cz plus d equals to 0. And this one is called a linear form of the equation of the plane. So today, this clip, we are going to go over several problems, okay, concerning the equation of the line and equation of the plane, and also several problems that we may have, okay, using the line or the plane. So for example, the first one, you need to find the equation of the plane. Okay, so usually, I mean, for this kind of problem, it would be better if you draw a picture. Okay, that will help a lot. Okay, and this plane is just passing through the point 1, 2, 0, and got a normal vector of 2, 1, 1. Okay, so this one will be very easy, right? Because everything is already done. Okay, so it means that you got your this one as your ABC, this one as your x0, y0, z0. So the equation of the plane, your a, and then x minus x0, your b, y minus y0, and your c, z minus z0 made equals to 0. And then you simplify a bit, so you got 2x, you got, oh sorry, the c is the c is simply 1. Okay, so you have 1, so you got a z. This one you got a negative 2, and a 0 equals to 0. So you have a 2x y, and the z minus 4 or equals to 0, or sometimes you write as equals to 4. Okay, so if you need to find the intersection of each of the axes, okay, so for example, the x-intercept, so it means that you let your y and z to be 0. So you got your x, your 2x as 4, so your x is 2. And the same token, if you want to find your y-intercept, so the rest, I mean z and x, will be 0. So you got your y as a 4, and your z-intercept, okay, will be your x, and your y become 0. So you got your z as a 4 as well. Okay, and to sketch the picture of the plane, usually we are going to draw this plane in the first octant, okay, only. All right, so here your x, your y, and your z, and it cut your x at 2, it cut your y at 4, it cut your z at 4. So this is what we usually draw, okay. So it looked like you got a triangle like this, but actually you got a three-dimensional plane or three-dimensional sheet of paper. So on the back of the ZY plane, actually you got something that going through the back of this, and on the back of your XZ plane also you got some sheet of paper going on the back of this, and go also downward from the floor on the XY plane, okay. So you got all the straight sheet of paper just like that. Think of it as like you have the straight sheet of paper cutting at one corner of the room, okay, and you just only see what inside the room, okay, but actually there is something else outside, okay. So this is the first problem involving the equation of the plane. So now let's see if you want to find the plane that it's passing through 3 points, okay. So you got your plane, you got one point as a P, you got one point as a Q, you got one point as the R. So you can just think of it this way, that here you have PQ and the PR as two vectors, okay, on this plane. Then you need to have the normal vector of this plane, the one that is parallel to the each and every vectors on this plane. So you need something that is pointing out from your plane, right? So basically the one that you need to think of is the vector that is perpendicular to both PR and PQ, okay. So this one can be simply PR cross PQ, okay. This is just a sketch, okay. So actually if you do the PR cross PQ, then from this one, the right hand rule, your end will point downward, okay. So let me just change a little bit. So this one will be a Q, this one will be your R. So then the PR cross PQ, now your end is pointing upward, okay. But actually you don't really need to set up the right direction, okay. This will be good enough, because roughly speaking your normal vector will be the cross product between these two, okay. So it means that you are going to find your PR, which is the R minus P, okay. So your R is 3, your P is 1, your I is 0, your P is 2, your I is -1, your P is -1. So it is 2, -2, and 0. And your PQ, which is your Q minus your P. So your Q is 0, your P is 1, your Q is 2, your P is 2, your Q is 1, your P is -1. So you got a -1, 0, 2, okay. So the cross product between them, so the PQ, we say PR first, cross PQ, it just simply IJK, and then 2, -2, 0, -1, 0, 2. Again, if you know how to do it very quickly, then you do it, right? So right now we just added 2 more columns, okay. So this one you got -4i, this one you got 0, and this one you also got 0, okay. So if you do it upward, you got 2k, but you do it upward, so actually you have -2k, and 0 for the I, and another 4j, which is -4j. So actually you have -4, -4, -2, okay. As I told you that actually it really doesn't matter about all the factor here, okay, because what we really need is a direction, either is pointing upward or downward the plane, okay. So if you guys are so good, then you may say that, hey, this is -2 and then it is 2 2 and 1, okay, and you can say that this is your n. However, if you don't know what the hell is going on, then here can be your n as well, okay, it doesn't matter. All right, so right now we have the normal vector. We got, actually you got 3 points, okay, that is on the plane, so you just pick one of them. So let me just pick the p, okay, the p. So the equation of the plane becomes a, so let I just use this one, okay, the one that we already reduced, okay, ax minus your first component on p plus your b y minus your second component and plus your c z minus your third component, okay, which is -1, so it is a 1, okay, equals to 0. So if the problem just asks you to find the equation of the plane like this, you can leave your final answer to be this equation, okay. You don't really need to continue any further, okay, to just make sure that you got the right answer. However, if you want, then here is a 2x and the 2y and the z equals to what? Here's -2, -4, so it's -6, and then 1, so it's -5, so it is equals to 5, okay. So here can be your final answer as well if you like, okay. So this is about the equation of the plane that is passing through these 3 given points, okay. So what does this mean? I mean, the plane seems to be pretty easy, right, in terms of equation. However, in terms of finding the normal vector, usually will depends on the cross product, which is a little bit difficult to find and really need attention on the calculation, okay. So let us continue on this one. We want to find the point at which the parametric equation intersect the plane, okay. So you basically you have the plane and then you got the line that it intersect this plane at one point, okay, at one point. So we are going to find this particular point, okay, this particular point. So this is pretty easy because again, what does this mean? This point is the sharing between your line and your plane, okay. So it means that at this coordinates, your x must be the same, your y must be the same, your z must be the same. And for the equation of the line, your x depends on one variable t, your y also depends on one variable t, your z also depends on one variable t. So why don't we just plug in your x here to be 2t, because it has to be the same, right? Your y to be 1 minus t and your z to be 3 plus t as the parametric equation of the line say. So you have 2 and 2t, 3 and 1 minus t, and 3 plus t equals to 1. And then you just solve for t, right? Because the only parameter that we have now is a t. So you got negative, positive 3, and 3 plus t equals to 1. So how many t left? So you have 8t, and then the 3 and the 3 happen to be the same. So your t is 1/8, okay? So it means that, if you want to find this coordinate x, y, z, so your x, the intersection point, okay, the intersection point will be the point x, y, z, where your t is 1/8, okay, on the equation of the line. So your x will be 2 and 1/8, so 1/4, 1 minus 1/8, and then the 3 plus 1/8, and it is 1/4, it is 7/8, and then 25/8. Okay, so that's the intersection point. All right. Okay, so if you want to find the intersection between the plane and the equation and the line, that will be pretty easy like this. You get? So now, if two planes are parallel, okay, this is the one property. If two planes are parallel, what does this mean? Okay, so the two planes are parallel, then it means that let's say this is P1, this is P2, the P1 will got their own N1, and the P2 also have their own N2, okay, but because your P1 is parallel to your P2, then it means that your N1 and your N2 must be parallel, okay, must be parallel. So if it's not parallel, then this is your P1 and this one may be your P2, okay, then it got the angle between two planes, okay, it got the angle between two planes. So this problem, we are going to find the angle between two planes, and which angle will determine the angle between these two planes. Let's say that the first plane got the normal vector as n1 and the second plane got the normal vector as n2, okay, and here is the angle between the two planes. You can see from the picture that this angle is actually the angle over here, right, because they are sort of the same thing. So here the angle between two planes, okay, between two planes is actually the angle between two normal vectors of the plane. Okay, so to find the angle between the two normal vectors, don't forget that we have u dot v equals to the length of u, the length of v, and the cosine theta, right? So this one you are going to find the n1 and then dot n2 equals to the length of n1, the length of n2, and then cosine theta. Okay, so here let me just shorten this a bit. Whereas your n1 is right here at your equation of the plane, so your n1, it is the one in front of your x, y, z, and your n2 the same thing, it is the one in front of your x, y, z, just like this. So it means that if you need to do a dot product between these two, you have 1, -3, 2, and then the length of the first one is 1, 1, 1 square, right, and the length of the second is 1, 9, 4, and then cosine of theta. So it means that right now your cosine of theta, it is happen to be what? This one happened to be 0. So you got 0 over anything, I mean square root of 3 and a square root of 14, but it is 0. So what does this mean? If the dot product equals to 0, then it means that your theta is pi over 2. So it means that your P1, it is actually perpendicular or orthogonal to your P2. Okay. However, if is not happen to be 0, then the cosine theta will determine the angle theta between your P1 and P2 as well. Okay, so the angle between these two planes, okay, depends on the angle between the two normal vectors. For this one, if you would like to find the distance, okay, d from the point, let's say outside the plane, to the plane ax plus by plus cz plus d equals to 0, then what will be that distance? Okay, so let's say that here's the plane and here's the point p1 outside. Okay, so usually when you got the plane, you are going to have one of the point that your plane is passing through. So let's call it the p0, and as you can see that your p1 is given, your p0 can be calculated, so you can immediately find the vector pointing from p1 to p0. Of course, I mean, you are not going to be very lucky that the vector from p1 to p0 will be the one that perpendicular to the plane, so that this length can be the distance between your p1 and the plane, right? Because the distance between your p1 and the plane should be the distance that is the shortest distance. So it's the perpendicular projection or the orthogonal projection from that point p1 to the plane, just like this. Okay, so can you imagine what happened to this kind of diagram? Okay, so this kind of diagram can, because you got the one that is perpendicular to the plane, right? So you immediately think of the what? Your normal vector n that is pointing orthogonal outward from the plane, and then here you have your vector p1 p0. So what is this one over here? It is actually a orthogonal projection, right? It's a projection from this vector onto this vector n, is it? So what you really need to find is this distance d. Okay, so the distance d from the previous clip, okay, looking at the projection of the vector a, okay, onto the the projection of the vector b onto the vector a. Okay, actually you got two formula, right? You got a scalar projection, okay, of the b onto a, which is called the comp. So it is the a dot b, and as I told you that it is over the vector a, so it will be over the length of the vector a like this, and the vector projection, okay, but this one, because you need only a distance, so it is a scalar projection will be good enough. Okay, so it is a projection on the normal vector n, right? So you need to find the length of n on the bottom, and then on the top you have your a. So your your b right now is p1 p0 as a vector and dotted with your n. Okay, so that will be the distance. However, don't forget that your dot product sometimes maybe it is a negative sign, so to got always a positive, because you need a distance, you just having the absolute value. Okay, so what will be this one? Okay, what will be this one? So let's say that your p1 is x1 y1 z1. Okay, your p1 is x1 y1 z1, and then your p0 is just simply the one that your x and your y are 0, and your z is simply negative d over c. Okay, so this point is 0 0 and negative d over c. Can you see it? Okay, so it means that your p1 p0 vector is a p0 minus p1. So your p0, it is 0 minus x1, and then 0 minus y1, and then minus d over c minus z1. Okay, this is this vector, and then you are going to dot with the n. So your p1 p0 dot with the n will be just simply the negative a x1, negative b y1, and then negative c of this d over c minus z1. Okay, this is a dot product. Okay, and then you are going to find the absolute value, right? So by the absolute value, you just pull out all the negative sign. Okay, but this one you calculate. Oh, sorry, this is positive c. Okay, you calculate it first, so you got negative d and then negative z1. So you pull out all the negative sign first. Okay, so what you end up with is a x1, b y1, and then it happen to be c z1, okay, plus d, okay, plus d, and of course, I mean the length of your normal vector n is simply a square root of a square, b square, and c square. Okay, so the formula of the distance d, so let us conclude it here. It is the absolute value of a x1, b y1, c z1 plus d over a square root of a square, b square, and c square. Okay, one thing that you may need to be careful is that here the equation of our plane look like this. Okay, so it is ax by cz and d is right here equals to 0. Okay, and the point p is x1 y1 z1. On some book this value d is on the right hand side, so the formula may change a bit. Instead of a plus d into a negative d. Okay, so this one depends on the setting of your equation of the plane at the beginning. On this one, the setting is ax by cz plus d. Okay, so it's the point is the distance between this plane and the point given there. Okay, all right. So how about the distance between two parallel planes? Okay, so if you got two planes and they are parallel, okay, so you got this one and that one. So one of the plane will got your n1, one of the plane will got their n2. So because they are parallel, so your n1 it is parallel to your n2, and actually your n1 is a k times n2. There's a 1k that can make it happen. Okay, however, in terms of practice, okay, so your first plane will be ax by cz and d1. Your second plane may be something else. For example, it may be a hat x, b hat y, c hat z plus d2. However, you can do the factorization, you can do the division to make your x, your y, and your z to have the same coefficients. Okay, but the differ will be only the d, okay, right here at the end. Okay, so it means that if you really need to find the distance between these two planes, of course it is again the perpendicular distance. A distance is simply determined by your d2 minus d1 with the absolute value and the square root of a1 square, I mean a square, b square, and c square. Okay, so it's actually the distance between your two constant d1 and d2 over the length of your normal vector n. Okay, however, the setting must be like this, that the coefficient of x, y, z of these two planes must be the same. Okay, exactly the same, right? So for example, if you need to find the distance between these two parallel planes, how do we know that it is parallel? Here we have got two negative 2 and negative 2x. So you rewrite it and then divide the whole thing by negative 2. Okay, so you have your first plane is x plus y minus z minus 5, okay, equals to 0. We all right? So you just move it right there. Your second plane will be your x and your y. You see, you divide the whole thing by negative 2, okay, and minus z. So if you divide this one by negative 2, you got a negative 1/2, but as you move it over here, you got a positive 1/2. So here is your d1, okay, with the negative. Here is your d2. So the distance between these two planes is just your d1 and your d2 together. Okay, the distance between them and the square root of the coefficient in front of x, y, z. So you got 11/2, okay, and then the square root of 3 as the distance. All right. So let us stop this clip over here, okay, and then for this clip you need to go back and see that if we want to find the distance between two parallel planes, what can we do? If we want to find the distance between a point outside and the plane right here, again this is plus d over here, okay, which formula that we will use. If we want to find the angle between two planes, okay, which angle that we need to looking for, okay, and if we want to find the intersection between the plane and the line, what techniques that we use. Okay, so we are going to see you guys on the next clip, and we have more and more example for you to go over. So we'll see you then. Bye bye.